Hey guys, how you doing? Again, we're looking at some of these word problems involving population growth and decay um, using exponential functions. So here you got a retirement community that increases every year by 3.5%. And the town started with 10,000 people. And don't forget, we have this growth function. I'll do P for population, right? Where you have some initial amount, subscript zero, always means the initial amount or the times zero. And then because we're going uphill, it's going to be 1 plus whatever our growth rate is. And T is the number of years, right? So I can, go ahead and why don't we find some ordered pairs T, P of T. And what did they ask for? They asked for 1 year, 2 years, 5 years, and then finally X years. And of course, what am I going to do? I'm going to plug those values in, right? So for instance, for 1 year, it would just be what? 100,000 times 3.5%. So that's 1 plus 0.035 or 1 plus 1.035, right? That's my growth rate there. That's my R. And I'm going to raise this to the first power, obviously. So pretty easy. I'm at 103,500. That was easy math. Probably didn't even need a calculator. Of course, the second year, what happens? The exponent goes up. That's why these are called exponential functions. And I'm going to go a little quickly now because you can easily see the pattern, right? This is 107, 123. And then finally 5 years, same deal. I'm just jamming this in the calculator. So for the fifth year, I'm up to 118,769. Excuse me. And of course, for X years, actually, I know it said X, but we should stay with T, right? So for T years in general, it's the formula I've been using, right? It's P of T would be what? 10,000. I'm sorry, 100,000. Hopefully I'm saying 100,000, even though I'm writing 10,000. Man, what a screw up that was, huh? I'm missing a zero on all these, although I have my answers correct on the left. 100,000 times 1.035 to the T. Okay, that's my function. And then finally, they ask, how many years will I get to 150? And of course, you could graph this if you like and just kind of scroll along and see when the Y coordinate hits 150. Let's do this one algebraically, though, just to shake it up. So I want the population to be 150,000. Right. By the way, this is what city planners do. In fact, this is what Upper Merion does, where we have to look at population growth models to decide if we want things like a new high school. Right. So if we're going to solve this, and again, I'll go quickly, hit the pause or rewind if I'm going too fast here. You got to divide by 100,000 on both sides. That's pretty easy math. Don't need a calculator to tell you this is going to shake out to be 1.5 on the left and 1.035 to the T on the right. And then here's a deal again, where you got to take a natural log on both sides or a regular common log. It actually doesn't matter which logarithm you take. And the whole point of taking a log on each side is you can bring the exponent down. So I get log of 1.5 equals T log 1.035, and everything is being multiplied. So to get T by itself, I would just divide out that log of 1.035. And again, your calculator eats this up. Just type it right in the calculator. And this is going to shake out to be about 11.8 years. About 11.8 years. So hopefully that video worked out for you.